Hey everybody, this is Gregory from Dapp University, and today I wanted to show you some real-life decentralized applications, or dApps, that are on the mainnet of the Ethereum blockchain. These are dApps that are used by real people, and we're going to take a look at some of those dApps. We'll see the user-facing features and how we might be able to interact with them. We'll also look at some metrics to see, how often these dApps are used, how many people are using them, how many Ethereum transactions are happening with these dApps. And we'll also take a look at the code behind some of these dApps. We'll be able to see the smart contract code that is deployed to the Ethereum blockchain. Now, if you're not familiar with what smart contracts are and how they work or what the code looks like, I've got a couple of videos that talk about smart contracts from a conceptual perspective and also walk you through the code of smart contracts. And I've also got a 2-hour video that walks you through building your first decentralized application, or dApp, step by step. So I'll put a link to those videos down in the description below. And you can also subscribe to the channel if you'd like to see more videos about how to build decentralized applications on the Ethereum network. First of all, I wanted to just highlight this discovery tool that I'll be using today, dappradar.com, which will show us a list of decentralized applications that are being used on the Ethereum blockchain. And we'll kind of use this as our fuel for our journey today. And I also just wanted to show this for your own kind of education. You can go back to this from time to time and check on dApps that are trending, dApps that are being used. You can filter them by the amount of Ethereum that are in the smart contract. This is the smart contract balance. You can see the 24-hour volume that has moved through the smart contract within the past day, the past week. You can see the transaction size. These are how many transactions that go to and from the dApps. You can see that for a day and also 7 days. So this is a fun thing to revisit from time to time if you're interested in how dApps are doing on the Ethereum blockchain and new dApps that you haven't heard of yet. So let's just kind of go down this list and look at a few different dApps on here. I'll highlight a few popular dApps currently and some famous dApps. And kind of just look at some of the different categories that these dApps are listed in and talk about them a little bit. So the first one is Ethereum, and this is a gambling or a casino dApp. It basically allows you to gamble your Ethereum cryptocurrency by digitally rolling dice and kind of betting on the outcome of that dice roll. So we can go ahead and click through to visit this dApp. As a terms of use, click OK. So yeah, this is just a gambling dApp where you would connect your Ethereum wallet and you would bet on the roll of the dice and the outcome. And, you would win some Ethereum or lose some Ethereum depending on the outcome of that roll. Now, I wanted to highlight, in order to use a dApp or a decentralized application, you need a special browser or you need some sort of browser extension. I can't just use this dApp by visiting this website with Google Chrome, right? It needs to know about my account that's connected to the Ethereum blockchain. Like, I can't even connect to the Ethereum blockchain with my browser as it is. So you would need something like Mist or MetaMask, which this is actually the MetaMask extension right here. And the MetaMask extension turns your Google Chrome browser into a blockchain browser. So if I wanted to use this dApp or decentralized application, I would just log in to do that. But I'm not going to do that right now because I do not want to gamble the Ethereum in my wallet at the moment. So yeah, if you were going to use any of these, you would need a special extension like that or use the Mist browser. And I talk more about MetaMask in my tutorial about how to build your own decentralized application. So if you want to hear more about that, you can check out that video, and the description will be down in the link below. So that's basically what you do here. You can read the rules about how to play the game. Here it talks about using a Mist browser or using MetaMask. It's pretty self-explanatory. So let's go back and actually look at the metrics of this dApp. You can see that there's currently 4,281 Ethereum in there. Let's pull up the calculator. I think right now Ethereum is about $850, 850 US dollars. We just had a big market correction. It was up to like 1,300, I think. So let's see, 850 times 4,281. That's let's see, 1, 2, 3, 1, 2. That's about a little over $3.5 million. So it's not a small amount of money that's sitting in this decentralized application at this point. 24-hour volume is 1,000 Ether, roughly. 7-day volume the past week is almost 7,000 Ether. I mean, it's there's a lot of money flowing through this app, put it that way. Transactions, 2,000 transactions within the past 24 hours. If you don't know what a transaction is, basically, anytime you write some sort of information to the blockchain, you create a transaction. So if I were going to send Ethereum from my wallet to yours, that would be a transaction on the Ethereum blockchain. If I was going to place a bet probably on this app, I would likely create a transaction on the Ethereum blockchain. So this is probably going to represent the number of times people have tried to roll the dice on this decentralized app. And actually, we can clarify that by looking at the code, which we'll probably do here in a minute. But for now, that's kind of just an example. So I'm actually not sure the difference between this balance and this balance. This might be, yeah, I'm not sure. So anyways, yeah, you can also see you can see those metrics over here on this graph: 7 days, 24 hours, 1 hour. You can see that, yeah, it's a lot of stuff. Oh, that's cool. I didn't even realize this. You can see the gas used. Yeah, that's cool. So let's also look here. You can see the address of the contracts. We'll take a look. Take a look at both of these. Looks like there were 2 addresses listed. You can see 1 and 2. So what we're looking at here, these are the smart contracts that are fueling the back end of these decentralized applications. And like I said, smart contracts are basically the building blocks that we use to build decentralized applications. And that's how we write code that lives on the Ethereum blockchain, and that's how we build our dApps. So let's take a look at the overview of each of these. So this website here is Etherscan. It is an Ethereum blockchain explorer. Basically what it allows us to do is see things like Ethereum transactions, and it also allows us to inspect accounts on the Ethereum network, and it also allows us to see smart contracts that are deployed to the Ethereum blockchain. So you might have seen something like Etherscan or a blockchain explorer before if you've ever made some sort of Bitcoin transaction or Ether transaction, and have waited for currency to be transferred from one wallet to another. That's a similar kind of thing. That's probably the primary use case, is people to watch transactions as they're being confirmed. But today we will use this to actually look at the code of the smart contracts that are fueling this app. So let's take a look here. So like we see, we have an Ethereum balance of 4,293. This is the same kind of metrics we just saw. Yeah, it actually calculated the US dollar value for us, which is nice. And the number of transactions. All right, so we can see that these are the transaction hash, you see, 11 seconds ago. So this dApp is very active. 2 minutes ago, 5 minutes ago, 5 minutes ago, 39 seconds ago. And we can see that these are pending transactions. So a pending transaction on the Ethereum blockchain is one that is waiting to be confirmed. Now, the Ethereum blockchain, how that works is anytime that a transaction is created, the mining nodes on the network compete to complete the transaction, and all the other nodes on the network work together to confirm the transaction based on the consensus algorithm. And this is all part of Ethereum's proof of work concept. So whenever we see something like this, that's exactly what's happening. the mining nodes and the network are still waiting to complete this transaction, and the other networks have to confirm it before it's going to get assigned a block number. And we can also see the account that these transactions are sent from. You can take a look at this account. We can see that this account has a, roughly $3,000 balance. It's about 4.5 Ethereum. We can also see the transaction hash. This is pretty cool. This shows us the gas limit, the gas used by the actual transaction, and the gas price. This is the gas price in Wei. Wei is the smallest unit of Ethereum. Basically, you can't divide 1 Ethereum any smaller than 1 unit of Wei. Something I talk about in my other videos on building smart contracts on the Ethereum blockchain. You can actually see the actual cost of this transaction was $2.43 in US dollars. That's the cumulative gas used. So yeah, some pretty cool metrics that you can see here. And these are kinds of things that you can see in your development console when you're building decentralized applications. I actually show you those in my 2-hour video where I take you step by step on how to build your first decentralized application on the Ethereum network. It's all information that's readily available on your local blockchain that you use in development. But here's a way that we can see, real transactions on the mainnet Ethereum blockchain. You can see internal transactions, event logs, also things that we can inspect in the Ethereum console. I guess that you can comment on these. This is just something that they've built into their website. I doubt that these are actually stored on the Ethereum blockchain. In fact, I know they probably aren't. Okay, also, so in this list of transactions, we can see that there's the account that these are sent from and the transaction hash. We can also see where these were sent to. This is the Etherroll smart contract. You can actually see that this is a contract by hovering over the item on the table. We can see the amount that was sent, so 3 Ether. Yeah, so somebody's, like $2,500 US dollars roughly right now that they're sending. You can kind of see how much people are actually gambling. 4 Ether. Pretty crazy. All right, so let's look at the contract code. I'm actually going to paste it into a text editor. All right, now we have some syntax highlighting that we can use to make it easier to read our smart contract code. So yeah, let's take a look at this. So you can see, our declaration of the Solidity programming language version at the top of our contract file. We can see this in the other tutorials where I show you how to write smart contracts. And we're using Solidity version 0.4.18. And this looks like this smart contract is using the Oracleize API. Now, sometimes when you're building decentralized applications, you have to rely upon an external source of truth outside of your smart contracts to provide them with reliable data. And that's exactly what an oracle is. And that's what the Oracleize API will do for you. So, for example, if you couldn't necessarily make some sort of API call about live, constantly changing data inside of a smart contract, because your smart contracts are going to get deployed to different nodes on the blockchain. And if those were to try to attempt some sort of call in and of themselves, like each smart contract could get a different result. So you must rely upon an external source of truth to provide your smart contracts with that data, and that's what an oracle is for. Now, I'm not 100% sure what the primary use case is for Etherroll and why they're using Oracleize. Off the top of my head, this is actually the first time that I'm looking at this contract code, so you're learning just as much as I am as we look at this. But just calling out that they're using the Oracleize API and that they've just injected it into this file directly. So I'm going to jump ahead to the actual smart contract code. I'm going to assume that it's called Etherroll, so let's just look for that. or I can look for a contract declaration. Contract ether. Yeah, I was right. Contract ether role. So yeah, I was right. This is the ether role contract, and it's using Oraclize. So let's just kind of take a look around here. You can see some function modifiers that have been defined. These are basically things that you can add to the functions to change how they behave. As we scroll down here, we can see state variables that are defined. If you've seen my other tutorials on smart contract development, you'll know that these state variables are what we use to change the state of our smart contract. And when we change the value of a state variable, we're actually writing to the blockchain. It's not just some value that's stored in memory within the contract, it's actually written to disk. So we can see that these are unsigned integers, Boolean values. These are solidity mappings, which are like associative arrays or hashes, and this is a nice robust way to store data in a smart contract. Basically, it's a key value pair where we have a bytes 32 string that corresponds to an address. This is the player address. This is the player's profit. So basically, this would be player profit would almost be like a table or something like that if you come from a different development background with a centralized database. This bytes 32 string would represent the player, and the unsigned integer would represent the amount of profit that they've received here. I'm going to assume that this is the way value for the amount of profit that they would receive. Again, way is the smallest denomination of ether. Basically, you can't divide ether any smaller than one unit of way. We have some events that are triggered, log bet. I'm assuming these are called in functions. These are events that you can subscribe to with a client, and whenever this event is triggered, you can basically get the transaction and inspect it and do something whenever the event is triggered. So function ether role, this is the constructor for the contract. This is the function that's called whenever the contract is deployed to the Ethereum blockchain. The owner of the contract is MSG sender. So this is the address of the person or the account that deployed the contract to the blockchain. The treasury is MSG sender. I'm assuming the treasury is basically the house in this case, since this is a gambling app. This is where all the ether will be stored for the house account. So these are some functions to basically initialize the Oraclize API, looks like. You can set the house edge. This is a 1% house edge. You can see that in the comment. That is what we saw in the, I think they advertised that. Yeah, it's a 1% house edge. So they're honest. They show that in the contract as well. You have a minimum bet. So here's some functions we see. This when the player rolls the dice, this is what happens. So this contract is payable. This is a function modifier. This basically means that the account that's calling this function can send ether to this function. Game is active. I believe this is a modifier that they defined up here. Yep, right there. Game is active. And bet is valid. Sorry for all the pink. I basically have my text editor set to show trailing white space. It looks like there's a lot of trailing white space in this contract code. So yeah, you can kind of see what's happening here. So that's what happens whenever the player rolls a dice. This is a callback function. This is player withdrawing a pending transaction. Yeah, set max profit. So yeah, you can kind of see what would, how many lines are required to build a smart contract that would fuel a gambling app like this. So a lot of this, like I said, is importing external libraries, and the actual smart contract code that powers this game starts here. So line 1700, and looks like it goes to line 2200. It kind of gives you an idea, and you guys can read through this contract code more yourself, but I wanted to kind of give you just an overview of what's going on and point out some familiar things that you should recognize if you've seen my other tutorials. So that gives you a behind-the-scenes look of a dApp that lives out there in the wild on the mainnet Ethereum blockchain. And you can kind of, we saw how many people are using it, how often it's being used, the number of transactions, the amount of Ether, and the code. So let's take a look at a couple more. The next one we'll look at is CryptoKitties. This is a pretty famous dApp because I think back in December, it got pretty popular, and so many people were using it that it clogged up the Ethereum blockchain and slowed down transactions quite a bit. So CryptoKitties is basically a collection game. So it's the kitties are crypto assets. So basically they're unique, just like a token would be. You can buy and sell them, and that's really what CryptoKitties is about. And you all can kind of poke around. You can see that CryptoKitties is a game centered around breedable, collectible, and oh so adorable creatures we call CryptoKitties. Each cat is a one of a kind and 100% owned by you. It cannot be replicated, taken away, or destroyed. Yeah, so it's a crypto asset. So let's take a look at some of the metrics here. CryptoKitties, the balance in the contract is 9 Ether. The volume is 101 Ether in the past 24 hours, 7 days. Yeah, so you can take a look at those metrics. So also, that's a game, and there's several spin-offs of CryptoKitties. There's like Crypto Countries. It's the same kind of thing where you can essentially, instead of buying a kitty, you can buy a country. So that's another crypto asset. Let's see. There's also like Crypto Cities, I believe. Yeah, so it's .net, .cities. I'm not sure what the difference is. Yeah, same idea. Another crypto asset, but it's a city instead of a kitty. So let's look at a different category. Also, yeah, so here's a marketplace, OpenSea. So you can see the volume here. Let's visit the website. So OpenSea is a marketplace where you can, it was like primarily for discovering crypto assets, but you can actually buy them and sell them as well. So that the assets are like CryptoKitties. Crypto celebrities is another kind of idea. It's basically a way of creating an asset that has, a face rather than just like a token or something like that. And OpenSea is a marketplace for that. We got CryptoPunks, Ether Tulips, MyEthereum, I'm sorry. Yeah. So yeah, that's a couple of different dApps in different categories. And you can kind of see a trend here that a lot of these dApps on the Ethereum network right now are pay-to-play decentralized applications. And that's because of Ethereum's proof-of-work model. So basically, the Ethereum blockchain, you need a wallet connected to it in order to use these dApps, and you must pay a transaction cost whenever you want to create a transaction. You must pay that in the form of gas. So it makes sense for a lot of these apps to be pay-to-play decentralized applications. And you can see that, with like a gambling app and these games and these marketplaces. These are some kind of early use cases that are obvious that people are using them for. All right, so I hope you all enjoyed that tour of different decentralized applications or dApps that are deployed to the mainnet Ethereum blockchain. Again, you can use DappRadar yourself to kind of look around and explore different dApps that live on Ether on Ethereum. And yeah, you can see there's some new ones that have popped up, and it's just a fun tool to use from time to time to go around, and you can get used to the smart contract code when you see it. If there are any other dApps that you all would like to see me walk through on the Ethereum blockchain, please leave a comment below. And if you want to learn more about building your own smart contracts and decentralized applications, you can check out my tutorial where I'll walk you through building your first decentralized application step by step. And if you'd like to see more tutorials about building decentralized applications on the Ethereum network, be sure to subscribe to the channel. And until then, thanks for watching DApp University.